This is question 17 in exercise 4.1 in Project Maths 3A. The cos of theta is 4/5 and theta is between 0 degrees and 90 degrees. So for part 1 of this question, we've defined as fractions the value of sine theta and the value of tan theta. The easiest way to go about doing that will be to put a little right angle triangle together to find the missing side so that we can find those ratios out. So if we mark out our right angle triangle like this, we mark our angle down here, that's our right angle there. So since cos theta is 4/5, cos is always adjacent side over hypotenuse. So if we mark our adjacent side here as 4 and our hypotenuse as 5, like that, then what we can do is we can use Pythagoras' theorem to find the value of our missing side, which we'll call x for the moment. So Pythagoras' theorem says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. In other words, from this one, it's going to be 5 squared is equal to x squared plus 4 squared. So 25 is equal to x squared plus 16. So 25 minus 16 is equal to x squared. So x squared is equal to 9, which means x is equal to 3. And once we have that figured out, we can then get the value for sine theta and tan theta. The sine of an angle is the measure of the side opposite it in a right angle triangle over the hypotenuse. So in this case, our sine theta is going to be equal to 3/5, and our tan theta is going to be equal to the measure of the opposite side over the adjacent side, and that's going to be 3/4, like that. So that's part 1 done. And now for part 2, we've got to first of all show that cos squared theta plus sine squared theta is equal to 1. And then we have to show that cos theta plus sine theta is greater than tan theta. Okay, well, cos squared theta is just the cos of theta squared, and sine squared theta is just the sine of theta squared. So we'll rewrite them. Cos squared theta is going to be 4/5 squared, and then sine squared theta is going to be whatever we got for sine theta, which we have down here, 3/5. And that's just going to be squared. That's equal to 1. And if we then multiply these out, part A, 4/5 squared is 16/25, and 3/5 squared is 9/25. 16/25 plus 9/25 is 25/25. And 25 over 25 is equal to 1. So we get 1 equals 1. So we have shown exactly what we were asked to show, that cos squared theta plus sine squared theta is equal to 1. So that was part A. For part B, we're asked to show that cos theta plus sine theta is larger than tan theta. Well, that's straightforward enough. Cos theta is 4/5, and sine theta is 3/5. And we're asked to show that they are larger than 3/4. Well, if we add 4/5 and 3/5, we get 7/5. And 7/5 is 1 and 2/5. So 1 and 2/5 is definitely larger than 1, and 3/4 is definitely smaller than 1. So we can clearly show that the cos of theta plus the sine of theta is larger than the tan of theta. So that's that done. And now for part 3, we've defined the measure of angle theta correct to the nearest degree. Now to do that, we can use either the cos, the sine, or the tan of the angle. It doesn't matter which one, but we may as well start with the cos because we were given the cos to start with. So we know that cos theta is equal to 4/5, which means that theta is equal to cos inverse of 4/5. And that we're going to have to go to our calculator for. In order to do this, it's going to be, we're going to press Shift and then the cos button, which will give us the cos inverse function. And then we're going to put in 4/5 into our calculator, so fraction button, 4, down arrow, 5. Then we press right, and we press bracket, which will close off the sum, and we should get a sum on the screen of the calculator that looks like what's written here, cos inverse 4/5. And if we press equals, we'll get a value out for theta. In this case, cos inverse of 4/5 is 36.86989,765. But we're being asked to get that correct to the nearest degree. So to the nearest whole number is what we're asking for that. So it's going to be equal to 37 degrees. And that is that.